The lesson topic for this video is Geometric Probabilities, Part 2. Alright, so this example right here shows, let's say, a red dartboard and a blue center on that dartboard. And if I asked you if we were going to throw a dart onto this dartboard and you get a prize if you hit the blue section, that is a similar problem as we were working on in Part 1. So let's go ahead and start that process here. The area of a large circle, we know area is pi r squared. So the area is pi times the radius. It would be helpful if I gave you some, information in the diagram. So let's see here. Let's make the radius of this entire circle. Let's make it 8. All right. And just so you know, I'll make the radius right now for the blue circle. Let's just go like this. The radius of the blue circle, let's make that 3. Let's say. Okay, so the area of the large circle is pi times 8 squared, the radius of the whole large red circle. That answers 201.062. And then we have to find the area of the small circle, and again, same formula, pi times the radius. The radius of the small blue circle is 3, so pi 3 squared, which is pi times 9, which is 28.274. So, again, similar to our previous examples in Part 1, the probability of landing in this blue section, which means you win, is the area of that circle, which we just found to be 28.274, out of the entire sample space. And again, the entire sample space that you could hit is the entire dartboard, the entire thing, including the blue part, so the whole thing, which is the area of the large circle, which was 201.062. And just for your information, that simplifies to be 0.141, which is about 14%. So 14% likelihood that you would hit the blue part out of the entire target. Now, today's lesson is going to be about the second question. What's the probability of landing in the red section? So somewhere in here. What's the probability of landing on one of these spots, not this? Well, since we already found the probability of landing in the blue bullseye, the probability of landing in the red section is actually pretty easy. And we'll talk about that. But what if I hadn't found this? Okay? If I hadn't found that yet, finding the probability of landing in the red section is a little tricky because we don't have a formula for this shape right here, the ring part that's outside the blue part. That, by the way, is called an annulus. And again, we don't have a formula for that that's straightforward. But we can get there. Mainly what you need to do in this case is we have to take the area of the entire circle and subtract the area of the blue part. And if we do that, what would we be left with? The red portion. Again, it'd kind of be like if you take the donut hole out of a donut, how much donut is there? And if I do that subtraction, if I do the 201 square units for the large circle and subtract out the blue part, which is 28.274, we will end up with 172.788 for the area of the red portion of the circle, and then that will be, of course, over still the total sample space, which is the area of the large circle, which is 201.062. And that will come out to be, if you find the decimal answer, to be 0.859, which is again about 85, almost 86%. And again, that makes sense because we had already said that this one right here was about 14%. Well, how much would be left? Well, 86%. So here's a second example using a similar situation. So let's say this is a placemat and a piece of food is dropped on it, and we want to know what the probability is that that piece of food landed on the blue portion of the placemat. Again, we don't have a formula, a simple formula for finding the area of that type of shape right there, but we do have an area formula for the entire rectangle as well as for the small rectangle that's on the inside. So in the directions it says the white portion of the placemat is 11 inches by 18 inches. Alright, so 11 by 18 for the inside white rectangle. Then it says the blue border is 3 inches wide. Now that means all the way around that's 3 inches. So right here, for example, from here to here, that border right there is 3 inches. And that's true anywhere in the diagram. So right here, that would be 3 inches as well. Alright, so find the total area of this placemat. Well, you can't just multiply 11 times 18 because that's not the area of the whole placemat, that's the area of just the inside. So we have to find this. We have to find the length of the placemat. Well, we know it's 18 units from here, in fact it's inches, 18 inches from here to here, and then how much longer is it? Well, 3 inches here and 3 inches here. So the 18 plus 3 is 21, plus 3 more is 24. So we know that length is 24. The same thing can be done to find the height. Again, we have from here to here is 11, and then we have 3 more units here and 3 more units here. So 11 plus 3 is 14, plus 3 more is 17. So now we can find the total area of the placemat by simply doing the base times the height, and that is 24 times 17. Again, not 18 times 11. That area is 408 square inches. All right. The next part of the question asks us to find the area of the inside rectangle, the white rectangle. Well, that one's a lot simpler. We just have to do the base times the height, which the base of the inside rectangle is 18, and the height of the inside rectangle is 11. That is 198. All right. So, what is the shaded area? What is the area of the shaded portion of this placemat? Well, that part is whatever the whole entire placemat is minus the part that is not shaded, which is the inside portion of 198. So all we have to do here is we have to take the 408 for the entire placemat, subtract the 198 for the white portion, and we end up with 210 for our shaded area. So then, back to the original question, what's the probability that if I dropped a piece of food on the placemat, it would land on the shaded or blue border portion of the placemat? And that answer is 210, because that's the area of that blue part, divided by the entire area of the placemat, which was 408. That ends up being 515. So it's about 51.5% likely that it would land on the bordered portion.